and we're going to start right now. So I think, again, what's important for me is that when you do these questions, even if you do them at home, that you try to do them without a calculator. If you do them without a calculator, you completely, you're completely missing the point here, because we're practicing for the Maths Olympiad, and so it's crucial that you do that without the without a calculator. So please refrain from doing that. Okay, cool. So let's jump straight into that first question. If you have done it, awesome. If you haven't done it, give it a bash. And then if you have done it and you've got an answer, don't tell me the answer, but type into the chat how you did it, and everybody else give it a bash. Or so Sakiwa, put into the chat how you did it. Olivia, put into the chat. Oh, there we go. Okay. Josh, that's good. Okay. All right. I think what's very important for me is that we need to, with so many Olympiad questions. Sorry. Okay, let me zoom in a little bit. All right, cool. I think what's important for me is that with a lot of these questions, we build up a pattern, right? So what I'm going to do is I'm just going to start really small, and I'm going to go 2 minus 1. And if I do that, I'm going to get 1. Then if I do 2 plus 4 minus 1 plus 3, I'm going to get 2. And if I go 2 plus 4 plus 6 minus 1 plus 3 plus 5, I'm going to get 3. All right. So in my mind, all right, what's happening here is everybody can see there's a pattern that is developing. And so for every number, and this is what Joshua alluded to earlier, all I'm doing actually is I'm going the 2 minus the 1, and the 4 minus the 3, and the 6 minus the 5, and I'm just going to keep getting a whole bunch of 1s. All right. And so the question is, how many numbers do I have in here? Well, those are the first 25 even numbers minus the first 25 odd numbers. And so my answer for those numbers is going to be 25. All right, cool. Excellent. Let's look at the next question. Double tapping on the screen doesn't work, Andres. This is Notability. I can just zoom in with my fingers. Okay. On the iPhone. Okay. Okay. I don't particularly like this question because the numbers that it comes out with they're not nice numbers. but the initial concept stands. So again, do this without a calculator. Okay, so someone tell me, what is my first step in this question? Anyone, what is my first step in this question? Cool, Josh, that's good. All right, so this I'm seeing as a difference of two squares, right? If it was x squared minus 1, I would factorize it as x minus 1 and x plus 1. But at the end of the day, what is x? X is a random number, right? And so if I can do it with x's, I can do it with numbers. And so that's really important because I can go and factorize this as 2014 minus 1 and 2014 plus 1. All right, and so what I end up getting is 2013 times 2015. This is a whole lot easier to prime factorize it's a whole lot easier to prime factorize than the initial number, or if I were to actually work out 2014 minus 1 and then try factorize that. All right, so what I would do for both of these is I would set out the ladder method, all right? And I would, rephrase. I would set out the ladder method and I would prime factorize. Here I can see into 2015 goes 5 and into 2013 goes 3. And so I would factorize it like that. The problem with this question is that the numbers that you get aren't particularly, I get 671 there, and I get 403 here. And to go find prime factors that actually multiply into this is quite challenging. And so I don't particularly like this question because we're never going to try with the Olympiad stump you with finding prime factors. The prime factors are generally going to be quite easy to find. What it ends up being is that 2013 is 3 times 11 times 61, and 2015 is 5 times 13 times 31. If we were to give you a question like this, we would make the prime factorization much, much easier. All right, but I think what's important is Josh's first step of using a difference of two squares to make it a little bit easier for ourselves. Okay, cool. Are there any questions with regards to this? No. Oh, there's more people joining. Okay, cool. So Shavanya, no. Like, in my mind, Stefan? No, it doesn't matter in which order it is. After I've gone and prime factorized 2013 and 2015, I would just probably order them from smallest to biggest. But again, specifically also for first round, there are going to be options for you. And so, you won't need to order them. Also, with regards to that, if this were a question in the Maths Olympiad, right, you would be able to very quickly identify that 3 goes into this, because 2013, the digits of 2013 add up to 6, which is divisible by 3. 2015 ends in a 5, which is divisible by 3. And so then I can go test values and see if 11 or 61 or 13 or 31 or whatever values they give to me in the solution set actually go into that. But yeah, okay. Stefan, I don't know if you are in, or Stian, I don't know if you are in grade 8. Are you in grade 8? Because this is just a factorized, okay, 100% Stefan. So unfortunately, this is a factorization technique that we learn in grade 9, I think, potentially in grade 8, but definitely you haven't done it just yet. And so, yeah, for the Maths Olympiad, we split it into grade 8 and 9. And so a question like this wouldn't be in your paper, but it would definitely be in the grade 9's paper. Okay. All right. Let's look at this question here. Give it a bash. One to 2, cool. I don't know if that's right. Just keep on going. Everybody keep on bashing away. Maureen, can you not hear me? Can everyone else hear me? Am I muted? No, I'm not muted. Retabile, yeah, that method of factorization you will learn fairly soonish. I think in the syllabus you probably started with number systems and exponents and algebra and FOIL, and I think after that comes factorization. It depends on how your teachers have set it up, but you will learn that. Okay, so someone else on their phone, maybe give Maureen some advice in the chat here about how to hear me, because I'm not sure how to do that. All right, so let me do this question. I'll show you how I did it. Yeah, okay, cool. Now again, there's multiple different ways to do it. If you get the same answer as what I did, very happy with what you did. So keep on going. Obviously, it works. But yeah, this is how I did it. As I said, RATE. All right, and they told me that the ratio of RA to AT is equal to 1 to 3. All right, but is everybody with me at the same time that this is also, if it's 1 to 3, all right, it could, I don't know what the values are. The values could be 2 and 6, right? So if I just, 1 to 3 is the same, so 1 to 3 is the same as 2 to 6, is the same as 3 to 9, is the same as 4 to 12, right? And so if they tell me the ratio here is 1 to 3, and the ratio from AT to TE is 5 to 2, all right, the way that I did this, all right, is I just got a lowest common multiple for 3 and for 5, all right? And so in my mind, and we're going to do a question like this also a little bit later, I'm sure there's other ways to do this, all right? Seems like Josh has got that way not quite nicely, but yeah, in my mind, I'm going to find the LCM for 3 and 5, and I'm going to get that it's equal to 15, all right? So I'm going to take this ratio of 1 to 3, and I'm going to change it by multiplying 1 and 3 by 5, right? And I'm going to get 5 to 15. Now, that's still a ratio of 1 to 3, all right? I've just changed it from 1 to 3 to 2 to 6 to 3 to 9, 4 to 12, 5 to 15. All right. And the reason I'm doing it, and you'll see where I'm going with this now, is if I change the ratio at the bottom from 5 to 2, 5 to 2 can also be written as 10 to 4, can also be written as 15 to 6. All right. And if I change the ratio from 15 to 6, does everybody now see that that piece in the middle there, A to T, is 15 for both of them? And so if I just go put that 6 there, and that 15 in the middle is common, then I'm going to get RA to AT is 5 to 15, which is 1 to 3. AT to TE is 15 to 6, which is 5 to 2. All right. And now I can very easily see that the ratio of RA to TE is 5 to 6. Okay. So in my mind, this is the easiest way for me to think about this. But if you look in the chat there, Josh's answer is also valid. But in my mind, I like thinking about it visually. And so I'm always going to draw a line, and I'm always going to find the lowest common multiple. And then I can compare the ratios if AT is a common number between both. All right, so that's how I did it. Are there any questions? Okay, cool. All right, let's do the next question. While you guys are doing it, I'm just going to quickly get a coffee refill. I'm going to do that in 2 seconds. So Olivia, we didn't do this one last week. We did a similar one last week where we had consecutive numbers and not, when I read this question, I read consecutive even integers. Yeah, we did actually do this number last week. All right, so change this question, do it again for me, and let's make it consecutive even integers. Sorry, we did do this question last week, so just change that number to consecutive even integers. That's how I read it. Okay, so it's 408. Okay, I think in my mind, I'm always going to set it up algebraically, just because, yeah, I'm just going to set it up algebraically. And if I do that, I'm generally going to start with a middle number. And the reason I'm going to start with a middle number is because when I move to the next number is going to be x plus 2 bigger than the previous number. And the next number is going to be x plus 4. All right. The second number is going to be x minus 2, and the first number is going to be x minus 4. All right. And why this works out quite nicely is when I go and add up all of these numbers, what happens is the minus 2 will cancel out with the positive 2, the minus 4 will cancel out with the positive 4, and all I'm left with is 5x, and the sum of all of these is equal to 2020, right? And if I go 2020 divided by 5, right, what I'm going to get is, so I'm going to divide on both sides by 5, and I'm going to get x is equal to 404. And so I know that the middle number is 404. Exactly the same technique that you would have done for the consecutive integers. Now we're just doing it for consecutive even integers. They could have done it for consecutive odd numbers. Yeah. Okay. Cool. Except it wouldn't have worked out for this question, but yeah. So I thought this was not the same question as last week. Apparently it was, but the same technique applies. Okay. This is a great question. Give this a bash. Haley, is that a question?
Yes, I couldn't hear you all this time you're speaking about this question.
You couldn't hear me? That's not a problem. You can go and listen to the recording. You can go listen to the recording of this question when it's posted online. Caleb, is that a question? Are you trying to join with your PC? That's fine.
Thank you, sir.
Okay. So the answer, I didn't actually say what the answer was. The next answer is going to be the middle number is 404. The next number is then 406, and the last number is then 408. Second number is 402. The first number is 400. Again, I like this method of choosing the middle number as x, because what happened is all the minus 2's and plus 2's and the minus 4's and plus 4's cancelled out, and my sum was just left with 5x. Okay, so, and once I have the middle number, it's very, very easy to go and figure out whatever they want us to say. So if they want us the second number, or the fourth number, or the middle number, or the first number. Okay, cool. So let's hit this question. Okay, there is an answer for x, Almaz. I've got 4 from Andres. Let's keep on going. I'm not sure if that one is right just yet, so let's just keep on seeing. So careful, Haley. Just think about what the original number was. So you're there, but you've overcooked it a little bit. So it's not 2 to the power of, it's 4 to the power of. Okay, so I'm getting a whole bunch of 4s. Let's just keep on going. Okay. So let me do this question. So if I ask you, is 6 a factor of 18? Like, I'm not quite sure if it is. All right. So what I'm going to do is I'm going to break. If 6 is a factor of 18, it means it goes into 18 perfectly. Okay. So yeah. So 18 times 18 divided by 6 will give me a nice answer. Okay. So all I'm going to do this question, I mean, obviously we know the answer is yes. All right. But all I'm going to do for this question is I'm going to prime factorize. Okay. If I prime factorize the top, what I'm going to get is 2 times 3 times 3. All right. And if I prime factorize 6, I'm going to get 2 times 3. All right. And now why that's really helpful is I can then go see, awesome. What's happening here is the 2's cancel, the 3's cancel, and my answer is 3. Okay. So in my mind, if I want to know if something is a factor of another number, all I can do is I can prime factorize the bigger number, prime factorize the smaller number, and then see, does everything at the bottom cancel out with something at the top? If it does, then yes, it is a factor. All right. And so let me move this to the side. All right. And the number at the top is going to be 1 times 2 times 3. And 4, I'm going to write as 2 times 2. 5, prime factor. 6, I'm going to write as 2 times 3. All right. 7, I'm going to write as 7. 8, I'm going to write as 2 times 2 times 2. All right. 9, I'm going to write as 3 times 3. And 10, I'm going to write as 2 times 5. Okay. Now, 4, all right, is 2 times 2. All right. And so the question is, if 4 were to go into this number, I mean, right, then what I want to know is I want everything to cancel out. All right. And so 4 I'm going to write as 2 times 2. All right. And that definitely cancels out. Beautiful. Okay. So 4 to the 1 is a factor. All right. But they're not asking what is the smallest integer value such that 4 to the x is a factor. They are asking what is the largest integer value. So if I go 4 squared, all right, that's going to give me 4 times 4, which again is 2 times 2 times 2 times 2. And there I can see, yep, there's 4 2's at the top. I'm good. All right. So let me try another 4. 2 times 2. All right. So I've canceled out those. Beautiful. All right. And I've canceled out those. So now I've got 3 4's. Okay. And let me try another 4. All right. Lekker. That's still canceled out. If I try another 4, those 2 at the bottom won't cancel out with something at the top, and I'm going to be left with a remainder. And so any more 4's won't cancel out from the bottom to the top, and so that fails. All right, so how many 4's did I have? I had 1, 2, 3, 4 4's, and so my answer is to the power of 4. All right, so in my mind, factors are always about if I want to know if a number is a prime factor, is a factor, prime factorize and see if everything at the bottom cancels out with stuff at the top. Okay. Awesome. So any questions? I know there's other ways to do it. This is specifically how I did it. This is the way that I find easy. If your way worked, excellent. But in my mind, prime factors are really powerful. So okay, awesome. Let's move on to the next question. Again, try be doing this without a calculator. Zora, doesn't 1 of the 2 times 2 count as the base 4? Yeah, 100%. So at the bottom, that's why I put those 2 together because that's a 4. And those 2 together because that's a 4. And these 2 together because that's a 4. And these 2 together because that's a 4. And so I multiplied 4 4s together, and that was 4 to the power of 4. I just broke it down into prime factors to see if it worked for me. Okay, so you could have just left it as 4s and created 4s at the top, but in my mind, it's easier to just go with prime factors. Okay, cool. Let's do the next question. Okay, so I've got an answer of 133. All right, maybe just explain to me in the chat how you guys got to that answer. Cool. So not 64 unrees, but pretty much, yeah. Okay, cool. So I get what numbers you're using, and I get that it works. But why did you get to those specific numbers? Did you just do it by trial and error, or did you how did you guys get there? Trial and error. Trial and error is a perfect method. All right. Trial and error, unreached prime factorizing. Trial and error. Under prime factors. Okay, cool. So trial and error is perfect, and if you got to this answer by trial and error, then that's excellent. But in my mind, I'm always going to prime factorize, and so if I prime factorize, I'm going to get 2 goes into 1,500 times, 2 goes into 500 250 times, 2 goes into 250 125 times. So when you're using the ladder method, I would always start with the lowest primes first. So start with 2, then go to 3, then go to 5, then go to 7, then go to 11. All right, so then I'm going to go, I see 5 goes into this 25 times, 5 goes into 25 5 times, 5 goes into this 1 time. And so the answer is I'm going to get that 1,000 is equal to 2 times 2 times 2 times 5 times 5 times 5. All right, now, the factors are always going to be a combination of the prime. The factors of 1,000 are always going to be a combination of the prime factors, right? So if I were to group those 2 and these 4, what I would get is 4, and 5 times 5 times 5 is 125, times 2 is 250, and that gets me to. And I'll answer your question now, Kara. That gets me to 1,000, so that's perfect. But again, the problem is that I don't want one of the numbers to have a 0 at the end. Now, can someone tell me why this has a 0 at the end? And we talked about this last week, but why does that number have a 0 at the end? Beautiful. All right, so the whole idea is how do you get a 0? Well, 5 times 10 is equal to 50. 225 times 10 is equal to 2250. And so the whole idea is whenever I multiply by a 10, I get a 0. But there I've got 2 times 5, which is 10. And so when I split this up, I can't have a 2 and a 5 together, because then I'm multiplying by 10, and that will give me a 0. And so what I have to do is I have to split put all the 2's together, put all the 5's together. Because if 1 2 is with the 5's or 1 5 is with the 2's, I get a 10. And so my answer there is 8 times 125. And both of those, when I add them, is 133. So 8 plus 125 is equal to 133. So that's quite a nice answer. If you did it by trial and error, that is excellent. But yeah, this is a nice way to visualize it because they can ramp this question up and then trial and error will be a little bit harder. And so I would encourage you guys to be thinking along the lines of what's it called? Prime factorizing. Okay. Is the ladder method the easiest way? I don't know, many other way, like split it up in like a tree method or something like that. I don't know. In my mind, I've always done the ladder method, but there are other ways to do it. However you get to prime factorizing, that's perfect. Kyra, you had a question?
Hi, Robert.
Hi, how are you? Hi,
It's
David.
David,
How are you
Robert.
doing?
Robert,
David?
there are 2 learners who said they're still waiting for the host to let them in.
Okay, I've let in 1 learner, Zandile.
Okay.
Sorry, I kind of just got carried away with the lesson and then stopped looking for people that wanted to join. I'm sorry, David. I will check every few minutes to make sure that I let people in. Okay,
No
but
problem.
yeah, so I've added now Zandile, but I don't know about the other learner isn't in the waiting room anymore. So just tell that learner to join the waiting room again and then they can join. Thanks, David.
Okay, thank you.
Thank you. Kyra?
So sorry. I was going to ask, if they ask us a question like this, could you also not go off of just like, or any of its factors? So for 1,000, like if we did multiples of 8, or no, multiples of 125, I know that if you times 125 by 8, you get 1,000 because like it's a decimal, I think. But could we do something like that?
Yeah, 100%. I think that was where, let me just scroll up. That's what Josh did, is he started by going 1,000 is 4 times 250, and then he realized that didn't work. And so he got 4 times 250. That didn't work. And so he took a 2 away from this and moved it across, and he got 8 times 125, and he saw that worked. All right. So again, Kyra, if you use prime factors, if you use it with trial and error, that's absolutely perfect. But in my mind, prime factorization is the easiest way to do this because it's the easiest way to make sure that there's not a 10. And again, in this question, trial and error was actually quite straightforward, but my comment would always be that it's not always going to be this easy to do it by trial and error. And so in questions that are a little bit more challenging, knowing how to do it with prime factors will really, really help. So yeah, 100%. If you did it by trial and error, excellent. When I was in school, I often did it by trial and error. If I didn't come right, then I would move to an algebraic kind of approach, to a prime factors approach, to a more rigorous approach to help me. But sometimes trial and error is so much faster. And so, yeah. Okay, cool. All right. Give this question a bash. Okay, so I've got an answer of 30 coming through. Not sure if that is right again, so just keep on going. 7, everybody. Cool. So I think getting a whole lot of answers that are 7. Awesome. So in my mind, what I'm thinking here is I'm going to use algebra for this. Again, I'm assuming a couple of, no, I don't actually need algebra for this, sorry. I'm thinking of more difficult questions along this line. This is actually we do this in probability in grade 10 and 11, all right? But this one, we don't need algebra, we don't need that method for, all right? So I would split them into camps, all right? So there's people that play tennis, people that play volleyball, and people that play both, and people that play neither. So I'm going to split them into 4 camps. I'm going to say, cool, there's a camp that does both. There's a camp that does tennis only. There's a camp that does volleyball only. And there's a camp that does neither. And if I add all of these camps together, this must be equal to 40. There is no other camp. All right. So did we do a similar question like this last week, Yolim? I can't remember that. Okay, cool. Well, regardless, I'm going to do this question anyways. So I know that both there's 6. So I know that tennis is 20. And so the people that do tennis only must be the people that do tennis minus the people that do both. And so this is just going to be 20 minus 6, which is 14. All right, because that section is all the tennis players. All right, split into those people that do both, split into those people that only do tennis. Then the same thing here. Those people that do volleyball, all right, must be those people that do both and those that do volleyball only. And so this is going to be 19 minus 6, which is 13. All right. And so the question is, what is this number there? All right. So I've set up an equation for myself and I'm just going to go 40. That is 20. So this is 33. So 40 minus 33 is equal to X, which is equal to 7. Okay. So, all right. So pens and bags potentially. All right. But yeah, so those are my, that is the way that I did it. So I kind of just split them into 2 camps. And then I said, let's go from there. All right. Cool. Is everybody happy with that? Are there any questions? All right. All right. So this is let's seeing as we've done. Yeah. Question. Was there a question?
No, sir. No one said no.
No question, Nakoto. All right, cool. So let me delete that. Let's do a question like this. So I'm changing the question, and let's say there is 42 students. All right. There are 20 students who do tennis and 10 students that do volleyball. Okay, so 40 students all do sport. All right, question is, how many, all right, do both? Okay, sorry, that's not going to work. Let's make it, let's make this 36 students. Or will it? No. Let's make this 24 students. No, sorry. What am I doing with my life? It was actually nice. Let's make it. Keep going back on this. 38 students. Okay, 100%. Yeah, that's those. The answer is 8. I think that's a little bit potentially complex without a sketch, and this is not going to come up. So let's actually leave that. Most of you are getting the right answer, so let's just move on to this question here. All right, the natural numbers are written in 7 columns. The square is drawn around a block of 4 numbers, and the sum of these 4 numbers is 312. What is the top left square? Go for it. Josh, I assume you did this question last night, Sam? Yeah, that's good stuff. Don't look at Josh's answer. Try and do it on your own. So it says here, a square block is drawn around a block of 4 numbers. So like that. That sum would only be equal to 24. I want the sum to be equal to 312. Okay. Did we, so just those people that are getting answers for me, did you guys do it by, just chuck in the chat there whether you guys did it by trial and error or if you guys did it by just inspection, trial and error? Mr. Park, are you asking a question? Okay, Sarah did it by algebra. Cool. Okay, cool. So again, I think for me, that was a mistake, cool, not a problem. All right, for me, trial and error is still an option in questions like this. But like I said, sometimes trial and error often becomes more challenging than an algebraic approach. And so what I'm going to do is I realize that if I look at this number, 9 is 7 times bigger. So if I were to draw this block, right? I could rewrite it as 2, all right? 9 is 2 plus 7, 3 is 2 plus 1, and 10 is 2 plus 1 plus 7, all right? And this is going to be the case everywhere, right? I mean, that number is plus 1, this number is plus 7, and this number is plus 7. So plus 1 plus 7 is equal to plus 8. So I can see there's a pattern there. And so all I'm going to do is I'm going to take that pattern, use it algebraically, all right, and write it algebraically. So if it wasn't 2 in the top left, the number to the right would still be plus 1. The number down would still be plus 7. The number down would still be plus 7. All right. And so now I have a block. And all I need to do is now I need to set up an equation, and I need to set all of these 4 numbers added together. It's going to be 4x plus 1 plus 7 plus 8 is equal to 312. So 4x plus 16 equals 312. Subtract 16 from both sides, and I'm going to get 296. Then I'm going to divide 4 by both sides. All right, let me quickly do that. So how often does 4 go into 296? 4 doesn't go into 2. All right, but it goes into 28 7 times. Carry the 1, and it goes into 16 4 times. And so I know that x is equal to 74. All right, and so the number in the top left is going to be 74. Again, firstly, I like the algebraic approach. Secondly, you need to be able to add and subtract and divide fairly easily. So that needs to be second nature. And again, what's absolutely crucial is that you read this question right. And so here they said top left, but they could have asked for bottom right. So then you're going to have to take 74 and add 8 to it. Or you're going to have to take 74 and add 7 to it. There was an answer with 81. Callum, did you by mistake look at the bottom left number and not the top left number? Okay, cool. So Callum got 70. He got the right answer, but he didn't then answer the question. So it doesn't matter which number you call x, but it's so crucial that whatever number you call x, you go and work out x, and then you calibrate or recalibrate to get the right answer. Okay, cool. Kiara, question?
Yes, sir. I honestly don't understand how to get to 7 and 8, sir. Can you please explain it to me?
Okay, cool. So do you see that if I look at this block, all right, how do I get from 4 to 11?
You add. Yeah.
You add 7, right? 4 plus 7 is 11. And how did I get from 5 to 12? Is I added 7, right? Now, the interesting thing is, again, it doesn't matter which block I look at. Here, I'm going to add 7, and here, I'm going to add 7. And so if I call the top left number x, the number to the right of it is going to be 1 more. And then to get to this number there, I'm going to add 7, which is going to be x plus 7. This number, I'm going to add 7, which is going to be x plus 1 plus 7, which is x plus 8. Okay. Cool.
Okay,
So,
thank you, sir.
Cool. All right. Let's look at these questions. These questions come up quite regularly, so let's give this one a bash. Without a calculator. If you do it with a calculator, you're just defeating the point of this question. Okay. All right, so a brute force approach is fine. So I can go 2013. Ooh, that's nice, Josh. All right. Not always going to work though. All right. But a brute force approach is potentially going to work. All right. But I mean, if they make the numbers bigger, if they make the numbers more complicated, then it's going to be really, really challenging. All right. So I don't want a brute force approach. There must be an easy way to do this. All right. There must be an easy way. All right. So Josh's answer is nice, but we're going to get to that right at the end because that is actually a grade 10 concept, or like a late grade 9 or an advanced grade 9 concept that you haven't even done necessarily just yet. So let's try and do this without that way, and then I'll talk about Josh's way. Okay, do you guys want a hint? Just put into the question, just put a question mark in the chat if you want a little bit of a hint. Again, has to be without a calculator. All right. So the problem is these numbers are unmanageable. Okay. So let me chuck this out there and see if this helps. So I'm going to say this. Let x be equal to 2000. Let's see if that helps us. So wherever you see a 2000, replace it with x. Wherever you see another number, replace it with an expression of x. So what I mean by that is, what is 2013 in terms of x? Beautiful. Okay. So Miss Nafsaria, that's excellent. That's exactly what I'm going to do. Okay, so Olivia, that's fine. Again, but when I look at something like this, all right, now it gets a little bit more complicated because now they're adding in even more numbers. All right, so they can make this question a whole lot harder by just going 1, 2, 3, 4, 5, 6, 7, 8, 9 squared. Minus 2 times 1, 2, 3, 4, 5, 6, 7, 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And if they do that, all right, then your approach by working it out on paper is going to take you years. Okay, so I would prefer that we understand how to do this without paper, because that'll be really, really helpful. Okay, cool. So let's do it. And then the next question is fairly similar, so we can use this technique in the next question. But 2013, like Ms. Nafsaria says, is, well, let's look at this last one. This is x squared. All right, cool. Is everybody with me that if x equals 2000, then 2013 is equal to x plus 13, because x is equal to 2000. So I'm going to go write that number there as x plus 13 squared minus 2. 2000 is equal to x, and 2013 is x plus 13. Okay. Now, what's crucial to remember, and this is huge, is this value is not equal to x squared plus 169, 13 squared. This question or this expression is x plus 13 times x plus 13, and I'm going to have to FOIL that out. All right, so for those of you in grade 8, this question might be a little bit beyond you because you haven't done FOIL just yet. All right, but if I do FOIL, all right, I'm going to get x squared plus 13x plus 13x is plus 26x, and 13 times 13 is 169. You need to know your squares. All right. And then this is going to be minus 2x times x is minus 2x squared. Minus 2x times 13 is minus 26x. And then I'm left with x squared. Okay. Now, what's really nice about this, Petrus, you're in grade 7. Okay, but you're doing well though. All those questions that we've done, you're doing well on those. Okay. Now, so for these questions, don't worry, Petrus. We are going to get to some easier questions just now. All right. So Kiara, let me finish the question, and then you can answer. Does everybody see x squared plus x squared minus 2x squared cancels? 26x minus 26 cancels, and all I'm left with is 169, and that there is my answer. Okay. So all I'm going to do always is pick a number, make it x, all right, get everything else in terms of x, multiply it out, and generally we're going to choose questions where all the numbers cancel out. All right, Sky, not a problem. We are doing some, Yassine, not a problem. We are doing some grade 8 and 9 questions, as this is specifically for the grade 8s and 9s, but there are some questions that you will be able to manage before and after this. So, but I do need to do these questions for the grade 8s and 9s. Okay, now my answer, my one thing that I want to add here is, I'm just going to make this a little bit smaller and move it to the side, is if you had said, let x equal 2013, all right, oh, you haven't done FOIL in grade 9 yet? Okay, you probably will before you do the Maths Olympiad. That comes very early on in grade 9, all right? But if you said x is 2013, then this would be x squared. 2000 is x minus 13, and 2013 is x, and this is going to be x minus 13 all squared, and I would get to the same answer. All right, so however you end up doing this, whatever you call x will still work out quite nicely in the end. Okay, Olivia, are you in grade 9? Okay, cool. All right, but you've still done it. Okay. Sarah, are you guys in grade 9? Haley? Okay, cool. And you did it quite recently, or did you do it in grade 8? You've just done it. Okay, not a problem. Okay. Okay, cool. All right. Now, so this is just, who was it that gave this other answer? Let me just see. This was Josh. All right, cool. So when you guys get to factorizing trinomials, and this is maybe for paper 2 for the grade 9s, when you get to that point, all right, if I did a substitution, I said let 2013, and this is just a little bit of extension, so this is just another nice way to do it, and 2000 equal y, then I'm going to get x squared minus 2xy plus y squared. And what's really nice about this is that you can factorize this as x minus y all squared. That is a perfect squared trinomial. And so what you're going to get is 2013 minus 2000 all squared, which is equal to 13 squared which is equal to 169, which is the answer. So that's even a little bit quicker, but that's not going to work in the next question. And so we do need to know this, but that's still a great answer that you did there, Josh. Okay, cool. That was just a little bit of extension. This question is fairly similar, so give it a bash. No, there's not going to be a break, Yassine. We are, we've got another 45 minutes. If you want to take a personal break, that's fine. But yeah, we've only got so much time. If you want to take a break, just take a break, and then you can just watch the video afterwards. Okay. Neo, cool. I'm not sure if that is the answer. So keep on going. I don't think it's that answer, Sky. I don't want to see calculators. No calculators for this question, please.
Okay.
Is that Wesley? All right. So, I'm going to do this question. Okay, so Unreal also got 0. Okay.
Also got skill.
Wesley, are you asking questions or can I mute you?
No.
Okay. So again, in this case, you can choose anything to be X. Okay. Now, in my mind, always what I'm going to be thinking is I want to choose something in the middle. So you can choose 100, that's fine. That's going to make your calculation a little bit harder. All right. So what I did when I did this is I made 125 equal to X. So I said X equals 125. And so there I'm going to get X. This is X minus 1. And this is X plus 1. And again, why I like this is a difference of 2 squares. And so that'll calculate out a little bit nicely. All right, so Olivia, if you chose 120, that's fine. You would still get exactly the same answer. All right, but in my mind, I'm always going to choose values that work out quite nicely. All right, and so I chose 125. 123 is therefore equal to 125 minus 2. And so this is going to be X minus 2 all squared. And 129 is going to be X plus 4. All right. Now all I need to do is multiply this all out. Okay. And when I multiply it all out, then the sum should be quite easy to do. But yeah. Okay. So Petrus, you chose 120 as well. Beautiful. So in my mind, it doesn't matter what you choose, but choosing strategically makes the sum a whole lot easier. So Almaz, I think specifically I chose 125 because that would make that sum a whole lot easier. Because 1 less and 1 more is x minus 1 and x plus 1. That's a difference of 2 squares. That multiplies out nicer than a normal binomial times binomial. And so I chose that one, right? But again, if you chose anything, then that's cool. Olivia, I wouldn't choose 120. I would at least choose one of the numbers that is already there. Okay, so I would choose 123 or 129 or 124, 125, 126. Or if the whole yellow section wasn't there and it was just 123 times 129, I would still choose something kind of in the middle, maybe, because that often makes the multiplication a little bit easier. But yeah, regardless what you choose, you're going to get the right answer. But I would choose, Olivia, something that is in range with what we're working with. Okay, so you still would have got the right answer, Olivia. But yeah. I mean, why would I choose a number that's there? If I were to choose 10, I mean, it's a silly choice. But if I do 10, then I'm going to get x plus 113 squared and x plus 119 minus x plus 114, x plus 115, and x plus 116. And so if I choose a number that is out of range, it makes the sum a little bit harder. Now, obviously, I chose a ridiculous case. Nobody's going to choose 10. But the point is still, the further you are away from the numbers, the harder it makes the algebra. All right. And if you do it like this, you might as well just multiply it out. You haven't achieved anything by choosing x equals 10. You haven't made it easier. And so in my mind, choosing values that are in range makes this a whole lot easier. Okay, cool. So I've chosen 125. I'm going to multiply this out. Again, what's crucial is x minus 2 squared is x minus 2 times x minus 2. Okay, and so I'm going to get x squared minus 2x minus 2x. I claw over the top and I claw under the bottom. All right, and I'm going to multiply that by x plus 4. All right, this guy, I'm going to get minus x, x squared minus 1. All right, that's a difference of 2 squares. Okay, what I'm going to do for this guy is I like binomial multiplied by trinomial a little bit more. And so I'm just going to swap that around. Doesn't matter in which order you multiply. And also I see that minus 2x times minus 2x is minus 4x. Okay, cool. So now I'm just going to continue with my simplification here. And I'm going to get minus x cubed plus x. Again, some of you wouldn't have done this just yet, so that's not a problem. This won't appear in your Olympiad, but I am preparing the grade 8s and 9s. So, and this might even be a grade 9 question, but it is important that we do a range of questions so that everybody is prepared for their paper. All right. Then I talk about clawing. So I'm going to claw over the top. I'm going to get x cubed minus 4x squared plus 4x squared minus 16x plus 16. All right. What I see is that the x squareds cancel out. All right. The 4x squareds cancel out. And all I'm left with is 21x plus 16. All right. And now all I need to do is sub in 125 into my answer and solve. Okay. Oh, sorry, I did that incorrectly. What am I doing with my life? All right, this was 4x minus 16x is minus 12x. And so it's going to be minus 11x plus 16. and I'm going to go minus 11 times 125 plus 16. This is a much easier sum to do than this original sum. Okay, so if you had done the original sum, it might even have been easier to do it just by multiplying it out using normal maths and using your multiplication techniques. But again, we can always add in a whole bunch more digits that makes it almost impossible to do it by hand within the allotted time of the Olympiad. And so using this technique to replace something with X is really helpful. Okay. Let's move on to the next question here. This is again a little bit of an easier question. We did some really hard questions just now, so let's going back to some easier questions. Give these to a bash. Shivani, just because it made the multiplication easier. So I put x minus 1 next to x plus 1, because when I FOIL that out, I get x squared minus 1. I don't get that middle term. So that's why I just changed it. If you hadn't changed it, you would have still got the same answer. Okay. All right, so I'm getting a whole bunch of answers that are, I'm getting a whole bunch of answers that are 72. Okay, throw into the chat how you guys did that. Okay, cool. Mr. Park, that's lekker. I kind of did it in little bits. All right, so dividing by 2.5 is a little bit challenging for me. And so you could have converted to seconds. That's lekker, Caleb. But yeah, I don't like dividing by 2.5, not so lekker, right? So all I did is I said, if 1 lap is 2.5 minutes, then 2 laps is 5 minutes. And in 1 hour, there's 60 minutes. All right. So in my mind, how many times does 60 go into 5? Well, 12 times. Cool. And therefore, in 1 hour, he can do 12 times 2 laps. I can't just do that. 12 times 2 laps, which is equal to 24. And then I'm just going to go 24 times 3, which is equal to 72. Okay. So in my mind, yeah, that's beautiful. I did it like that. Okay, 100%. So like however you do it, like, yeah, try to make it a little bit easier for yourself. So dividing by 2.5 minutes, converting it to seconds, all of these are options, all right? But my way, if you can see, makes it so much easier. Getting 5 into 60, or even getting 5 into 180 is so much easier. And so, yeah, that's kind of how I did it. However you did it is fine, but always in my mind, I'm going to change the question a little bit just to make it easier, make the arithmetic a little bit easier for myself. Okay, cool. hit this question. So just as an insert, Andres, in my mind, 2.5, this is what I tell my students, is equal to 2.5. Like if you go into Excel, all right, and you just change the format, a point or a comma end up being the same thing. So for multiplication, I tell my students that it's only multiplication if it's in the middle of the line. And the same thing would be followed by the Maths Olympiad. Okay, so that would be my comment on that. Okay, there's only one cup. All right, so in this case, Petrus, I like your answer. Give it to me in fraction form. Okay, cool. So I'm getting a whole bunch of answers there. Okay. The way that I'm going to do this is I'm just going to talk about parts. All right, so this is a straight ratios question for me. Ratios and proportion and raters are all kind of in the same category. And so I'm going to talk about the cub. And I'm going to start. And so Sipasile, let's give us a answer in... give us an answer in fraction form, please. In my mind, Haley, fraction form, please. In my mind, the cub will eat one part a day. All right. So the question is then, how many parts does the lion eat? Well, it says here, a lion eats in 1 day as much as the cub will eat in 11 days. So if the cub eats one part a day, right, in 11 days, he'll eat 11 parts. And that's what a full-grown lion will eat in 1 day. And so a lion will eat 11 parts a day. All right. So in total, all right, the cub and the lion are going to eat 12 parts. Okay, 11 of those will belong to the big lion. One of those will belong to the cub. All right. So how do I find out what one part is? Because that's what the cub is eating. Is I'm just going to go the total divided by 12, and that gives me an answer of 2,0 something. And so yeah, I'm going to leave it like this. I'm going 25 kgs divided by 12 parts will give me one part. And what did the cub eat? One part. All right. Again, this is crucial that you read the question. All right. Because if they had asked, how much does the lion eat in 1 day? I would work out what one part is. This is one part. And then I would multiply it by 11, because how many parts do I want? I want 11 parts. All right, so it's important that, again, exactly like we did with the algebra, whatever you do, you have to make sure that you answer the question So whether you're working out 11 parts or one part, the process will be the same, but the way that I end the question will be different. And so that's something you need to take care of. So just read the question very carefully, because I can tell you right now, in the Maths Olympiad, they will put in all the options that are viable options. They will put one part in and they will put 11 parts in. And so if you do the wrong calculation, your answer will still be in the list. And then you'll be like, lekker, it's in the list, and then you'll go for it. But then that's the wrong answer. So just because the answer that you work out is in the list doesn't mean you've done it correctly. And so that's very important, is you actually answer the question. All right, cool. It's on the 11th of March. Okay, cool. So do this question for me. So I'm going to do this in two ways. The first way is a little bit of a brute force way. The second way I like a lot. Okay, so Josh, did you go through every single step? Or did you work out what you did earlier, the initial fraction? What did you do? Okay, cool. Going through every step is a perfect way of doing it. Okay, no calculators. Again, this is crucial that your arithmetic is good and fast and accurate. Okay, so Josh, go back to that rate question, RATE, and try do it like I did it there, or like you did it there. Okay, cool. So it seems like I'm getting a whole bunch of answers that are 600. So let me do it. They say one small cartridge can do 360 pages. They say four small can do as 3 medium. All right. So what is 4 small cartridges? Well, 4 small cartridges is going to be 4 times 360, which is 2 times 720, which is 1,440. All right. This is 3 small. This is 4 small. But 4 small is equal to 3 medium. So how do I work out what 1 medium is? I'm just going to go 1440 divided by 3. All right. 3 goes into 14. 4 times, carry 2, 8, 0. And so I know 1 medium cartridge will have 480 pages. All right. Now, I'm going to start and I'm going to say, it says 5 medium cartridges. Well, how much is that? Well, that's going to be 5 times 480. All right. So how am I going to do that? I'm going to go 5 times 400 is 2,000. 5 times 80 is 400. And so this is going to be 2,400. All right. And then I'm going to go, but that is 5 medium. All right, and they want to know what is 4 large. For those of you who were with me last year for these lessons, Almaz, do you guys remember doing this question? I'm pretty sure we did this question last year. All right, but this is equal to 4 large. So all I'm going to go is 2,400 is the same as 4 large, and I'm going to go 2,400 divided by 4 is equal to 600. That is the correct answer, just like that. Okay. Now, alternatively, this is the way that I thought of this. And I'm going back to the same way that I did the rate question. All right. So if you did the rate question otherwise, you would have got the right answer. But in my mind, this is how I did it. As I said, 4 small is equal to 3 medium. All right. Una Mandla, can someone help Una Mandla about how to hear me? I don't know if they're on a phone or a laptop. So someone give them advice for laptop and or phone. Now, is everybody with me that this is all about ratios? All right. And so if I do 4 small is equal to 3 medium, this is the same as saying 8 small is equal to 6 medium. Is everybody with me? Cool. So I can ramp up that ratio as much as I like. Then they tell me that 5 medium is equal to 4 large. All right. And exactly like I did in the rate question, I can go, instead of going from small to medium to large, I can go directly from small to large by changing the ratios so that that middle section is a lowest common multiple, and then I can go straight from small to large. All right. So the lowest common multiple between 3 and 5 is 15. So I would have to multiply the first ratio by 5, and I would get 20 equals 15. And I would have to multiply the second ratio by 3, and I would get 12. So I know that 20 small is equal to 12 large. Okay. So all I'm going to do is I'm going to go 20 times 360 divided by 12, and that will give me 4 large. And now I can see quite easily, I can cancel out all of this so quickly. All right. I can see 12 goes into 36 3 times, and so is going to go into 360 30 times, and so I automatically, that's going to be 1 large. And I'm automatically going to get 20 times 30 is 600. And so that for me was a much quicker way to do it. It included less arithmetic. And yeah, again, not necessary, but sometimes when the numbers get bigger, sometimes when the question gets harder, it's nice to use ratios. And in my mind, making it visual helps a lot. And it helps with just understanding the problem, specifically because I'm visual, but everybody is different. So however you got to the answer, I'm happy. Okay. Everybody happy with any questions? Petrus, is that a question or is that yes, you happy? Okay, yes, you're happy. Okay. Petrus, would you be able to do it with the ratios as well? Quite nice, eh? Okay, sweet. All right. Okay, Petrus, however you do it, perfect. All right. Now, let's do the next question. Okay, so let's just focus on the questions. It's only 15 minutes left, and that person who couldn't hear can just watch the recording. So is that a question? No? Okay, cool. All right. So, in my mind, I'm dividing 7 into 2. And so 7 doesn't go into 2, so I'm going to look at it into 20. Into 20, it goes twice. right? 2 times 7 is 14, and I leave 60. Into 60, all right? 7 times 8 is 56, and so it's going to go 8 times, and I'm going to leave 40. How many times does 7 go into 40? 5 times, and I leave 5. 7 goes into 50 7 times, and I leave 1. 7 goes into 10 once, and I leave 3. 7 goes into 30 4 times, and I leave 2. And boom, 7 goes into 20 twice, and I leave 4. And does everybody see what I'm there? I have my repeating pattern, and so the pattern is always going to be 2 5. So my answer is going to be 285714, 285714, 285714. And so I can see that my decimals recur every 6 digits. All right. And so they want to know what is the 2019th digit. All right. So in my mind, every multiple of 6 is going to end in, well, what is the multiple of 6? It's 4. And so all I need to do is I need to find the closest multiple of 6 to 2019 and then adjust it. Okay, so I'm seeing a whole bunch of 5s. Now, even if you've got 5, I like this method that I'm about to do. So everybody just watch this. All right. Divisibility by 6 means that it's divisible by 2 and it's divisible by 3. So if I look at 2019, all right, and I add the digits together, I'm going to get 2 plus 1 plus 9 is equal to 12. And so I can say 2019 is divisible by 3, but it's not divisible by 2. So everybody, that's not going to work for me. But if I add 3, all right, because it's already divisible by 3, so the next number that's going to be divisible by 3 is 2022. All right, that's divisible by 3 and it's divisible by 2. And so I know, and if it's divisible by 2 and 3, that means it's divisible by 6. And so 2022 is a multiple of 6. And therefore it means it's going to end in a 4. 2021 therefore ends in a 1. 2020 ends in a 7, and 2019 ends in a 5. All right. And so a whole bunch of you got the right answer. So well done. All right. But yeah, however you got there, I'm happy. But I like that method of just finding the closest multiple of 6 and then working from there. I specifically said 2019 and I went up. But if you went 2019 minus 3, you would have got 2016. This is a multiple of 3 and a multiple of 2. So therefore it's a multiple of 6. And then you could have worked from 2016 and worked to the right and not to the left like I did. But yeah, however you end up getting there, beautiful. All right. Did some of you just go like this? 2019 divided by 6. Did some of you do that? Okay, Mr. Park, that's beautiful. Still got to the answer. But are you happy that my way is a little bit quicker? But yeah, however you did it, I'm happy. Okay, cool. So we've got 10 more minutes. So I really want to do this question. Let's do this question. This was a nice question. I'm just going to take this and make it a little bit bigger for myself. Sorry. Just so that it's going to be easier to draw on. I'm not sure if there's extra lessons during the week. I know that I do the Saturday one. Ask on the group. Ask on the classroom. I don't think there are. But yeah, give this one a bash. Okay, Petrus. So C needs to be a angle. So it needs to be 30 degrees. It needs to be 60 degrees. It needs to be actually an angle in degrees. Okay. Cool. So this is the last question I'm doing. Okay. So they are telling me angle A, oh, sorry, that was incorrect. Angle A is equal to 2/3 times angle C. Not quite, Josh. So what I'm going to do is, everybody happy that I can say angle A to angle C is 2/3. All right, so the ratio of angle A to angle C is going to be 2 to 3. That doesn't mean 2 degrees to 3 degrees. It could be 4 degrees to 6 degrees. It could be 6 degrees to 9 degrees. So all I'm going to do is I'm going to say angle A is 2x and angle C is equal to 3x. All right, so I know that the ratio is 2 to 3. All right, but I just don't know what the multiplier is. So I just need to figure that out. Oh, no, I think you are right. Josh, I think you are right. Sorry. I was thinking about what the value of x is. All right. So now in my mind, they tell me, and they tell me that B and C are supplementary. So they're telling me that this is 180 degrees. And so that means B is equal to 180 minus 2x. All right. And they also tell me that D is 2 times B. So this one must be 2 times 180 minus 3x. Okay. Or let's do this. Let's do it another way. If the other side is 180 degrees, it means that this is also 180 degrees. And it means that this, oh, sorry, did I say 3x there? 3x, this is 180 minus 2x, the angles. All right. Now, what I know about all of the angles in a revolution is they all add up to 360. All right. And if I do that, that's not going to work. All right. But I do know that 2 times angle D, so 2 times this angle, 2 times angle B, 2 times angle B is 180 minus 3x, is equal to angle D, which is 180 minus 2x. Okay. Now, all I need to do is I need to solve for x. So I'm going to multiply that 2 in, and I'm going to get 360 minus 6x is equal to 180 minus 2x. I'm going to subtract 180 on both sides, and I'm going to add 60 on both sides, and I'm going to get 4x. Now I'm going to divide both sides by 4, right? And I'm going to get x is equal to 45. All right. And so I can then say, if x equals 45, that means C is equal to 3 times 45, which is equal to 135. All right, so that was quite a tough question. But yeah, in my mind, with questions like x, if they ask for the value of x, always what I have to do is set up an equation. This question was even more challenging because I had to choose values that were X. And so this is what I did. Yeah. Okay. Are there any questions with regards to this question? Quite a cool question, I thought. I like this question. Okay, no questions. Okay, cool. All right, awesome. So I'm going to call the lesson there. I know that the assignment 2 is going to go up. I think the answers to assignment 1 are also going to go up on the Google Classroom. And I do know that the recording of this lesson will also go up. So if you missed some of the concepts I did, you missed some of the lesson, you can just go back and watch that again. But yeah, thanks so much, guys. Have a wonderful day. And I'll see you guys next week.